Now, so far we've been dealing with what we would call explicit functions, ones that are strictly as arithmetic sequences or geometric sequences. We're now going to move on to something that can potentially combine attributes of both, which we call difference, or more recently we've changed the name to recurrence equations or relations. There can be a common ratio or a multiplier, and also a common difference. So these are equations we'll be looking at that can potentially combine attributes of both a geometric progression and an arithmetic progression. Now please notice we will use and have to define either T1, which will mean the first term, we get the second term, the third term, or T0, the initial term. Quite often we use T0 when we're dealing with time factors. Now, in question 1, we're dealing with arithmetic sequences. So they will take the form of Tn plus 1 is 1 times Tn plus the common difference. Or Tn plus 1 is Tn plus d. So when we look at the first case here, we want to write the first terms out. We've got 15, and we add 4 to that, 19, 23, 27, and 31. We think of difference equations as the next term is equal to the previous term plus the difference. In the next case, once again, it has to be an arithmetic progression because the common ratio is equal to 1. So if I want to write out the first 5 terms here, I've got 30, 28, 26, 24, and 22. For C, once again, we start with the term of 3, and we're building on that by 1.5. So a common difference of 1.5, an arithmetic sequence. In D, please notice here I've used T0 as my initial term, not my first term, my initial term. It'll work out exactly the same way as things progress. So negative 13 plus 6, negative 7 plus 6, negative 1, 5, and 11. So it's a different way of expressing an arithmetic sequence. We're dealing with the next term, the base of the previous term, plus or minus a common difference.